8. The largest volcano on Mars rises 27 kilometers above the surrounding plain and covers an area roughly the size of Romania. Even if the Earth's gravity were as low as the gravity of Mars's, no volcano of such size could exist on Earth, for the Earth's crust, although of essentially the same composition as that of Mars, is too thin to support even a small fraction of that mass and would buckle under it, causing the mountain to sink. Okay, so this is telling us that the biggest volcano on Mars is 27 kilometers above the rest of the area, and it's roughly the size of Romania. And we're also being told that even if Earth's gravity were as low as Mars's gravity, we couldn't even have a volcano like this because the Earth's crust is too thin to support that kind of a mass, and it would buckle and it would cause the mountain to sink. To solve this question and to get to the right answer, you need to be able to understand that there's a conditional reasoning thing here. And to recognize that, you don't necessarily have to pick up on indicator words, but you need to pick up on the idea of necessity. In the middle of the stimulus, they tell us that no volcano such a size could exist on Earth because Earth's crust is too thin, which tells me that to have a volcano of large size, we need to have a crust that's thick enough. So this tells me that a thick crust is necessary to have a large volcano. So I'm going to write that down as part of my conditional statement diagram so I can map out what's going on. So if we have a large volcano, that means we have a thick crust. And then that means our contrapositive is if we don't have a thick crust, then we don't have a large volcano. This is what I know. I don't know anything else. Um, if the statements above are true, which one of the following must also be true on the basis of them? So I'm looking for something that has to be true every single time. A, the surface of Mars is less subject to forces of erosion than the surface of the Earth. I mean, I have no idea. We don't even talk about erosion here, so I can't possibly support this. So A is out. B, the highest volcanoes on Mars occur where its crust is thickest. I think B is a great trick answer. We know that to have a large volcano, we need to have thick crust. We don't need to necessarily know that it's at the areas where the crust is thickest. Like maybe spot A is thick and spot B is thicker, but maybe spot A is thick enough to still support the highest volcano on Mars. We don't know that. And we don't know the opposite either, so I can't support B. C, on average, volcanoes on Mars are higher than those on Earth. I don't necessarily know this either. Higher doesn't necessarily mean more mass, and it doesn't mean larger. It could just be taller, but it could cover less area, which means it's not as big or as large as something else. So I can't necessarily support this. D, the crust of Mars, at least at certain points of the planet, is thicker than the crust of the Earth. And this makes a lot of sense because there's at least one spot on Mars where there's a large volcano that can't be supported on Earth because the Earth's crust is too thin, which means that at least at that point, we need to have crust that's thick enough to support that volcano so it doesn't buckle and sink. So this makes a lot of sense. And then E, at least some of Earth's volcanoes would be larger than they actually are if the Earth's crust were thicker than it is. So this seems like a mistaken reversal just because the Earth's crust is thick. And I'm going to write E for Earth. This is what they're implying. We have a thick crust on Earth, so that means we're going to have a large volcano. But if you look at this and compare it to that original conditional statement that we had, it's a mistaken reversal. We switch the two sides, but we don't negate them, which makes it incorrect. And we're left with D.